This question says, what mass of nitric acid is needed to make 315 milliliters of a solution with a pH of 2.27? So as we talked about in the previous question, nitric acid is a strong acid. So whatever the concentration of H3O plus is also equal to the concentration of the nitric acid. So in this case, we need to find the concentration of H3O plus. So if you'll recall, the pH equals the negative log of the concentration of H3O plus. Well, if we rearrange this equation, the first thing we want to do is multiply or divide through by -1. It doesn't matter. The negative pH equals the log of the concentration of H3O plus. And then to get rid of the log, we take 10 to the power, which on most calculators is the shift log or the second log. And what we find is that the concentration of H3O plus, because this gets rid of the log, equals 10 to the negative pH. So in this case, we need to find the concentration of H3O plus by taking 10 to the negative 2.27, which this 2 is not significant, so the 27 is significant. So 2 sig figs is basically what I'm saying. And when you do that, you get 5.4 times 10 to the minus 3 molar. So that we know the concentration of H3O plus is 5.34 or 5.4 times 10 to the minus 3 molar, but we also know that this is the concentration of HNO3 because for strong acids, the concentration of H3O plus and the concentration of the strong acid are the same. Well, now that we have this information, what we can do is basically Gen Chem 1 problem. We want to make 315 milliliters of a 5.4 times 10 to the minus 3 molar solution. So we need to do dimensional analysis. Specifically, we need to take liters of HNO3, convert it to moles of HNO3 using the molarity, and then finally convert it to grams of HNO3 using the molar mass. So liters to moles to grams. Starting with, not milliliters, but liters, 0.315 liters of this HNO3 solution times. We're going to use the molarity to convert it to moles. This is the moles in 1 liter. So I put 1 liter of HNO3 on the bottom, and the 5.4 times 10 to the minus 3 moles of HNO3 on the top. All right, because this is moles per liter. We put the 1 liter on the bottom so it cancels, and the 5.4 times 10 to the minus 3 moles on the top. Now we need to look up the molar mass of HNO3 or calculate it, which is 63.01 grams. So we have 1 mole of HNO3 on the bottom per 63.01 grams of HNO3 on the top. And when you do all that math and you round to 2 sig figs, you find that you have 0.11 grams of HNO3 in this solution with a pH of 2.27.